In this problem, you're given the function values of f of x, y in a table. Some of the function values, I guess. And our region is defined by the interval 2 to 4 on the x-axis and the interval 0 to 4 on the y-axis. I'll draw that for you in a second to show you exactly how that determines your rectangle. And we're asked to find or estimate the function value. Excuse me, we're asked to estimate the double integral of f of x, y, dA over that region R. I'm going to do part B for you. I'll let you do part A. So let's get a handle on what this region looks like by drawing it. Okay. So let's see. Just marking my scale marks. 1, 2, 3, 4. Just going by ones. I'm going to do that on both axes. Okay, the interval from 2 to 4. It's critical that you realize the y interval goes from 0 to 4, and then you can actually identify where the lower side of your triangle is. It'll actually be at the height this gives you. So it'll go from 2 to 4, and it will actually be on the x-axis. So this would be the lower side of R. And then vertically it goes from 0 to 4. So your left-hand side of your rectangle looks like this. So R is here. Okay, so then we are asked to estimate the double integral with m equals 2 and n equals 4. M is the number of subintervals on the interval from 2 to 4. So we'll just break the interval from 2 to 4 up into 2 subintervals. N equals 2. So there's the subintervals from 2 to 3 and from 3 to 4, all we need there. And then n equals 4. N refers to the number of subintervals on the interval from 0 to 4. So we'll break the vertical side of the rectangle up like so. And then we'll put in some grid lines corresponding to the endpoints of these subintervals. And we get 8 subrectangles. We break up the region R into 8 subrectangles that way. And then you need to remember that the double integral can be estimated using what we call a double Riemann sum. We can take the double Riemann sum. The first sum would be from I equals 1 to m of the sum of j equals 1 to n. We estimate the function value at some sample points from each of these subrectangles. Doesn't have to be the midpoints. So I'm just going to write sample point, f of the sample point here, and we multiply by delta A. So that's one way to write the Riemann sum. Now we're never going to write it this way. At least in these problems, we don't have to. We're actually just going to write out the sum longhand. Okay, so how do we determine our sample points? Well, it tells us. We're going to use the lower left corner of each subrectangle we've created in this grid. So the sample points, here's a lower left corner, that's 2, 0. That's the lower left corner of this subrectangle. We'll go up from there. Here's a left corner, 2, 1, 2, 2, a lower left corner, 2, 3. And then here's the lower left corner of this subrectangle, and then we'll go up from there. That's 3, 0, 3, 1, 3, 2, and 3, 3. So our sample points are just what I said, 2, 0, 2, 1, 2, 2, 2, 3, and then 3, 0, 3, 1, 3, 2, and 3, 3. So what are we going to do? Well, first we need to find delta A, so let's do that. So how do we find delta A? Well, remember what delta A is. Delta A is delta x. It's an area element of one of these subrectangles, delta x times delta y. How do you find delta x? Well, you take the right endpoint of the x-axis interval, 2 to 4, so you take the 4 minus the 2 and divide by the number of subintervals, just like when finding delta x in Calculus 1. So 4 minus 2 divided by, there's 2 subintervals. So it's b minus a divided by m in this case. And then for delta y, you're going to take d, which is 4, minus c, which is 0. So subtract the endpoints of the interval from 0 to 4. And divide by the number of subintervals, which is 4 in this case. And let me make that look a little better. You get this. And notice both of these are just 1. So delta A in this case is 1, but it won't always be. So when you want to find the Riemann sum, which is your estimate of your integral, you're just going to take delta A, which is 1, times the value you get when you add the function values of all your sample points. So it'd be f of 2, 0, f of 2, 1, add it, and then all the way through to the last sample point plugged into the function to get the height value. So take your delta A times the sum of the function values of all your sample points. And if you go back up and how do you get these values? You just, normally you're given a function, but here you're given a chart. So it's just as easy. F of 2, 0 through f of 2, 3 would be given by these values. And f of 3, 0 through f of 3, 3 would be given by these values. So you're going to be adding 4 plus 3 plus 0 plus whatever that was. I think it's negative 5. Plus 7 plus 8 plus 6 plus 3. And, you know, the 1 doesn't do much in this case. So I can just drop it. 4 plus 3 plus 0 plus a negative 5 minus 5, same thing. Plus 7 plus 8 plus 6 plus 3. If you add all those together, you should get an estimate of 26. And it really is an estimate, so I should make it a little wavy equal sign, a very rough estimate, in fact. There you go.